Hi everyone, I'm Samson Koshi. Today I'm going to walk through an introduction with AIStor's S3 RDMA. The topics that we're going to cover today is mainly around the use cases and just give you a general idea on where RDMA fits into that picture, as well as what RDMA is in general, and then why we would want to use RDMA. And I hope that you get an understanding where RDMA is fitting into MinIO. At the end of this introduction, I hope you get an understanding of the use cases around leveraging RDMA itself as a feature in AIStor and have an understanding of the power of RDMA technology in general. So let's go through what RDMA is. So RDMA stands for Remote Direct Memory Access. What that means is like you have information on memory, let's say, and you're telling the NIC card, hey, Nick, get that memory address that I have sent you on the memory and pull that information and send it over to this other host that I'm providing. And I have already told the other NIC on the other host where to actually store the data that you're getting from this memory in your machine. And so that NIC understands where to put it on the memory on that machine. That's essentially what it is. And so that is kind of like what RDMA is. So let's go through a few RDMA use cases. These are certain spaces around which you might want to use them, especially in distributed storage clusters. MinIO is also one of them, where it could leverage to move data across multiple nodes. It also could be used for replication purposes, site-to-site replication, active replication that we have in MinIO, for instance. And so there are lots of other needs related in this sphere, especially when it comes to low latency and high throughput. In AI and machine learning space, you could think of training data that you want to train on an iterative basis, trying to find the local minimum or the global minimum or the local maximum and global maximum, depending on the problem that you're trying to solve in a faster manner as you are copying data over the network into your GPU memory. And then on the high performance compute cluster, it's mostly about ultra low latency information that can be transferred across the nodes to meet application needs. And another sphere is the streaming analytics and real-time data processing. And this is a classic use case on the Spark cluster, for instance, where you have a lot of data shuffling that's needed across multiple nodes, as well as when you want to persist information and retrieve information from S3 APIs that MinIO supports. It is also useful to do a real-time processing as well as cases where you need very high throughput. For instance, you are trying to aggregate billions of raw data or cleaned up data into aggregated pieces of information that could be data products that machine learning stakeholders or data scientists might use. Before I get into what RDMA is, I would love for you to have a good picture on where MinIO sits in the modern architecture. So you can see on its left side of where MinIO's data infrastructure is streaming information that comes in as inputs, either through a PubSub kind of system mainly, or queuing kind of systems. And then as it gets persisted in an object storage manner, you would see you could utilize different toolkits from data processing to process the data, either to produce data sets that are meaningful for insights and for machine learning purposes. And also you could leverage machine learning tech stack to load the data right into your GPU memory and applications that either sit directly on MinIO or on the machine learning, for instance, or even for the data sets that are produced from data processing to retrieve the information straight from MinIO or through machine learning, for instance. So those data sets, as they get processed, cover a couple of things when it comes to S3 over RDMA. One is handle low latency as quickly as you can over the network with minimal impact to your CPU. That means like your CPU utilization would be reduced, as well as for high throughput use cases. So why RDMA? It's because, as I mentioned a little bit earlier, but here I'm giving a little bit of an illustration, you can see that the kernel buffer is missing on the RDMA copy from server to server. So you can see that as data gets from the disk, it goes to the kernel space and then to the user space, which is the app buffer. But for the RDMA case, it bypasses the kernel going down to the kernel, but straight into the NIC. This is the part where you're telling the NIC, hey, NIC, go and take this buffer from memory related with the user space and copy it over to the other NIC, your friend. And I've already told your friend NIC to go and store that on the app buffer in that machine that NIC is on. So in summary, what we have covered is a few use cases just to give you an idea about where RDMA can be useful. Some takeaways, quick takeaways for that is think of low latency needs and think of high throughput needs and a combination of both. We talked about what and how RDMA works, and then we also talked about why we even use RDMA. Thanks for listening.